All right. Welcome everyone to the Habitat demos for July 28th, Friday. We just had a release yesterday, and there's a lot of great stuff in it. We're going to show you some stuff from that release and also some stuff that's coming up pretty soon. Why don't we start here with Ian, who's got some improvements to plan and knit.
Cool. Oh, and thank you for switching that. Now it's automatically, I guess, sharing my stuff. So can everybody see that window? Okay. Good. Okay. Yeah. So we're making some changes to the PlanInit subcommand. I was actually hoping to have this like 2 days ago, but of course work gets in the way of work. So I haven't opened the PR yet. I'm just been playing with a couple of functionality changes here at the very end of things because I'm also a perfectionist. But effectively, what we want for our user experience as new users come into Habitat and are ready to kind of start building things. And it sounds like, Salim, you can't see my window.
I can see it.
Okay. Weird.
Well, if everybody else can see it, it's fine. But
yeah, I don't know. I don't know what the deal is there. I'll try and reset it. And if not, then hopefully the people that are watching on YouTube or watching it later will be able to see it. I guess we'll be able to tell later on. But
I can see it now. I just had to click on it. That's all.
Oh, okay. So what we really want for new users coming into Habitat and starting to use Habitat is kind of the lowest barrier to entry as possible, as far as like potentially having a built Habitat artifact with as few steps to getting there as possible. So some of these changes are in support of that. And what that does is the concept is that it's going to build on top of all the work that Fletcher's been doing for our scaffoldings, and use that as the default interface for plans when a new Habitat directory is initialized. So you can probably see down here that we have like I've got three directories. These are not real applications. But if we look at the my Go app dir, we can see that we've got a godeps directory, and inside that godeps directory, we have a godeps.json file. So what we want to do is as a new user, effectively, we want to assume that the user has installed the Habitat binary and run the hab setup command. From there, the next step in getting started with Habitat or writing a plan is to use the habplan_init subcommand. So by default right now, when you run habplan_init, you're going to get a 358-line long plan that includes all the documentation, all of the plan options, and links to all of the things. And it's a little bit overwhelming for new users. And for longtime users like the core team, it gets annoying to have to delete 400 lines of content every time we want to write a new plan. So effectively, what we can do now with the new habplan_init subcommand, the idea is if we run habplan_init, we're going to get some output here. Oh, I did this in the wrong directory. 1 second. Run that again. Effectively, what hab's going to do is it's going to try to, since I didn't tell it what kind of app we're building, it's going to try to discover what my code base is. We have some simple checks based on the current context that you run this command in. Effectively, this discovered that we had that godeps.json file, and so it's decided that the app is going to be a Golang app. So what that means is that I've also kind of cleaned up this output to make it a little bit shorter, easier to read, and not as long. So what that should do now is we should have a Habitat directory with some stuff in it. And if we cat the Habitat plan, you get this really, really lightweight thing down here, which is barely even a plan, right? And effectively what it does is it takes the name of the directory to decide the package name. Because it's assuming that we're working in the root of our source code. It takes whatever you've set up in your habplan setup as your origin, as the origin, and then it determines what the code base is and plugs in the appropriate scaffolding from a package ident that is based on the list of available scaffoldings that we have in the project. So the rest of that stuff that used to get put out is still available. We can actually now do, like, if we want to clean that up. We can actually now also pass in a with all flag, which is going to give us all of the plan options when we run that. They'll all be commented out, but you'll have all of them, and they're there, and it's less noisy. And then the other thing that we can do is if we pass in, there's another flag for, we can do with all and with docs. I think it's with docs. Did I put it in there? Oops. Oh my God. You're going to get the documentation as well. So all that stuff is available, but it's opt-in as opposed to opt-out. And I'm trying to put as much into like the output here with links of things to read and information that's useful without like bogging everybody down. So we can do that right now for the 3 available scaffolding types that we have kind of in the works, which is Node, Go, and Ruby. But there are also times where you're going to have an app that maybe doesn't have a scaffolding, or you want to specify a scaffolding. So you can do that as well now. So you could actually pass in scaffolding Ruby, and you'll notice that it's going to tell you that we're going to use the Ruby scaffolding for core scaffolding Ruby. It's going to plug that in and give you all of this stuff. Now, in the case that we can't discover what your code base is, we can still run this, and we'll still get some output. And effectively, we're not going to fail by default. What we're going to do right now, and I'm expecting that this will change. Like realistically, we should probably ask for user input or give the users an option in case this fails. But the first iteration, what it does right now is if we can't determine what your source code is, then we're actually going to give you that with all version of the plan. Like so. And then, of course, like we've got some information here as far as if you don't know what you're doing, you can just easily pass in with docs and or go check out our plan syntax documentation. So that is it for me.
All right, great work, man. So this isn't out just yet. This is something that Ian's been working on in his spare time, and it's something that we hope that we can deliver soon. This is exactly what we had intended, which is using that scaffolding to automatically fill up the plan for you, and using the generator to figure that out as well. These we think are huge developer improvements. We've also made some in the last release around the studio. If you want to hit those next, Fletcher.
Yeah. Okay. I need to share. Yeah, Ian's work is pretty darn awesome. I'm really looking forward to it, and I think you're going to see this amazing payoff as a first-time Habitat user as well. We've got some nice plans without really changing anything. You've got like 3 things to do, anyways. So what I'm going to show is something that we've shipped in this last 027 series of release. So I'm going to do this in just a Docker container that has the hab binary. And I'm also root. This is going to work though if you're a Mac user using or Windows using like the Docker Studio, or on a Linux system either as root or non-root. So like the normal behaviors, it's just there'll be a couple little changes, little implementation details here. So I'm just going to enter a new studio, and you'll see this was just a clean image. So normal behavior here of downloading the studio and then downloading all the software that we need in the studio. So what I'm going to show here is something we're doing new with the studio, which is when you install a package, you have an artifact cache. So it's basically, if you've looked around under /hab cache artifacts, you'll see all these .heart files, which are the Habitat package artifacts sitting around. The unfortunate thing that people have started to notice the more they use Studio is we're kind of re-downloading your whole world for you every time. Once you're in the Studio, those hearts that are already around, you can install like off them, and everything's good. So here we're in a studio. If I tail the log, you can see I've missed it a little bit, but we're like installing the supervisor. There's the launcher. If we looked at the top, you'd see it was downloading all that software. So that's kind of normal behavior. And if we look in the artifact cache, let's make this a little smaller, you'll see like basically there's everything we need to download for me to enter this studio, which is kind of a lot. So if I exit now, though, I can show you, again, this is me as a root user. I'm outside the studio now, so I'm going to show you system artifact directory. I should have shown you that it didn't appear before. If I wasn't a root user, this would be under my home directory under .hab/cache and artifacts. So this lets me, I completely clear this studio out, so we're starting from scratch. Normally you'd see like now I've got to download everything again. And what you'll see this time differently is we don't have the download progress bars, we have verifying instead. So what's going on is that pool of hearts is now mounted into this new studio, and when we're trying to install the latest of everything, we're still doing the check to the depot to make sure that that we don't have a later version, if we're just going to download a normal package. But because we've done this backline and all the dependent software, we're basically just installing this out of the cache. And if I look at the supervisor is already loaded, because all the software is there now, it's got a lot less work to do. And you can see this same directory is filled up. So if I was to start building like a Rust thing and a C-based project and a Ruby app, you're just going to start to accumulate all these extra hearts over time, and they're going to be basically, you could think of it as being in your home directory now outside of the studio, and you're sort of like reaping the benefits of doing that work. So this will still require an internet connection, because there still will potentially be pings back to the depot, and anything new is going to be downloaded. But it means that you can be running these studios and clean them up and still have kind of like a much quicker build time, I'm hoping. That was kind of one of the reasons that we did this, is to get a better kind of feedback loop. This could also help on Builder, but that's sort of like incidental. And we'll have, currently you could try this out. I'll say for people who are probably watching this a few hours from now, go ahead and try it out with the latest version. That's the 0.27.1. We're just pushing our Mac build out. So if you happen to be watching this live and trying the Mac one, maybe just wait an hour, and then you'll get it. So the other thing I wanted to show, and I think Jamie can probably tack on what he's going to do onto this. This is kind of a small collection of additions on the supervisor for flags. So if I was to just show our load options, which is kind of the same as before, we've got basically two new things that you can sort of pack onto a service. And you can think of this as sort of a tag or a tuple of structured things that are no more than information right now. This is something with some work we've done recently that we're going to probably be able to exploit and use a bit more. But this might be useful for people today. This is a way that you could try to tie a whole bunch of services and services groups together in order to describe what you're running. So we've kind of called that an application. So think of it as like Facebook runs one application, and it's called Facebook. And there might be databases and app things and caches and queues under the hood. But there are all these services that kind of like, roll up to sort of provide this one sort of like application experience. So that's kind of what what we're referring to as application. And then this other idea of an environment, which kind of maps, I think if you're an application developer, that I think probably makes sense already. Like it's production, it's pre-prod, it's UAT, it's development, that kind of thing. So the idea is that we would, you kind of describe these things together. So if I was to say, I've got this, now let's say this is, we're at Twitter. And so what I'm going to fire up is a Redis service group for our Twitter application, and this is going to be in a production environment. Again, these are just labels, so there's nothing kind of new or fancy going on. It's actually writing off of the service group identifier. So if I was to go and do this, and then tail the supervisor, you can see right now kind of where this is manifesting itself. Normally, you would have just seen this Redis.default. That's like our normal service group. But you'll see now that we've sort of qualified this idea of a service group with this notion of like an application environment. So there's our application name of Twitter, our environment of production, and this hashtag is kind of the split between the two. So they're kind of a very tightly coupled set of information, the application environment, and the CLI flags will nudge you to like use both if you want to use both. And that's, I think, about it for that. Does that sound right? Did I kind of cover everything?
That sounds right, man. These are huge improvements to the speed in the studio, and I was just using them the other day, and it's so much faster going in and out of studios now, and all of our build workers are faster because of it, and such a small obvious change, but optimized later, you know.
Mm-hmm.
Fletcher, did you want to hit on your next bit too, or?
Do I have something else?
Application environment flags.
Oh, that's what I just did here.
Oh, I'm so sorry.
That's all right. So the events flag, or whoever was going to talk about that.
That's right. That's how that rolled.
Somewhat related.
Yeah. Sure. Let me take care of the events flag. So gotta share my screen here. All right. Let's see. So there's a new flag on run, which is this events flag. What this does is there's another server that you can run called the event server that's packaged up and deployed out to the depot, the public depot. And by running the event server, it collects data from the different supervisors and allows a collector to pull the data from it and then visualize it in a particular way. We've had the event server available, and it's been like debug hacked into the supervisor for a little while now. But this is the first time that it's actually fully hooked up. So basically, when you run a supervisor, if you type --events and you give it the service group of running event server, they'll auto-detect event servers, connect to them, and then send data to them about what's happening in a census ring. Why this is important, or why this matters, and why we couldn't just put a collector in the ring is the architecture of message flow in our gossip ring is peer-to-peer, and there's no guarantees that if you put something in a particular area that it wouldn't be part of a net split, or it wouldn't be reporting information incorrectly about the state of the ring. So instead, what we've got here is this event server that will send changes to the census data, and eventually other applications can tie into it. So like InSpec and things like that could send data through this that are running in the supervisor. And then also Heartbeat. So later on, we can visualize and say, yeah, these are all the running supervisors. These are the service groups they have. This ties in really well with Fletcher's work that he just showed of the app and end flag, which allow you to group that data as well. You collect it and visualize it, and you could show, for instance, a group of supervisors that work together to provide all the services of the acceptance environment of Builder, say, or the production environment of Builder. This is just table stakes for that. But the neat thing is that they all automatically find each other. So if I just looked at what's actually running here on this acceptance server, you'll see that events here is set to the event serve, and then over on this server we actually have an event server running, and everything in this ring just auto connects, sends its data, and then there's a collector running somewhere else that's pulling that, and we're prototyping some other work. So yeah, that's the event server. We didn't really talk about that in our release notes this last release because unless you build something to collect the events, it's not really that interesting. I've got a couple more things too. We implemented a new command on Hab called departure. Let's see. It would be helpful if I remembered where it got mounted to instead of the debug place. Adam, do you remember?
Yeah, it's Hab Butterfly.
There it is.
Ah, right. Okay.
Thanks, man. That's right. Config is an alias for a part of this. All right. So Hab Butterfly depart. So basically, what this does is it takes a member ID and it's a kick ban for supervisors. So if you have a bunch of supervisors running in a ring and you want one of them to leave the ring, you can send this message to kick it out. Also, if you have members that have been sitting there and they're confirmed dead and you know they're gone, you can also run this command. It'll kick them out as well. What this is useful for is basically, you have in leader election topology, you have to establish a quorum. And as members grow, that size of the quorum changes. And as members are left off as confirmed dead or they're just missing, they're unable to participate in the election. And by clearing the size of dead members, you're able to actually achieve that quorum and you won't just deadlock, right? You want to? Is that a good explanation, Adam? I think that you got a better one for me here.
Yeah, I mean that's all true. I mean the other thing that departure does is it'll happen automatically. So once a member is confirmed dead, after 72 hours, it will then get marked as departed, and departed nodes no longer count for the census or any of those other things. The other thing that happens is if you launch a new instance into the same service group. So so there's a new member that joins and it publishes a service on the same service group as an existing, and that service group has confirmed members, then we will automatically mark nodes as departed. So if you think about the auto scale use case where you have a cluster and everything's cool and half the cluster dies, and then you bring up a bunch more nodes, how do they then get back to consensus? And the answer is we mark those people as departed. If those departed nodes come back, so let's say they disappeared because it was a net split, and they come back and they were marked as departed automatically, then they will resurrect themselves. They will actually fully come back from being departed. They'll be like, yo, everything's cool. It was just a net split. Don't sweat it. If you use the departure command, so what Jamie's showing here, that exists to allow an administrator to say, this node is gone, this member is gone, and it should never come back. So a good example here would be you're running a database server, and your longtime leader has died, and other new leaders have taken over, and you would never go back to that former database and like turn it into a replica. You would kill it and start over again. And if it does come back, you wouldn't want it to ever come back and like resume its former operations. It should really just go away forever. And so when you run that depart command, what you're saying is this member can never, ever, ever come back. And if it tries, the supervisor just shuts you down. Like the supervisor will just give you a big message that's like, hey, you tried to kill me, and don't come back.
Yeah, I don't particularly want to depart something from the acceptance cluster right this minute. But if we ran it, it would stop execution. And then if we tried to restart the supervisor, like Adam said, it would just let you know, like, hey, you have to remediate this before the supervisor could start again. A way that you could do that is just deleting its data directory, or I think we need to have some sort of command to fix that up if you want to reuse the infrastructure.
We should give a quick shout out to the console developers at HashiCorp, because that departure design was Armon. So
absolutely, yeah.
Thanks, guys. That was awesome.
Extension of Swim, right?
Yeah, sort of. And also, if our implementation sucks, that's not their fault. But
yeah.
So
last bit here that went in with release was a number of critical bug fixes to go along with departure that we found while testing this feature. Super big thanks to the guys over at GE. They helped us find, and SmartBee, they helped us find some issues in our health checking. Basically, the biggest issues were all around determining who was alive if a supervisor was running more than one service. During some circumstances, they would be reported as basically in limbo, nothing, to a lot of their peers, which would then stop you from automatically discovering things. Rolling updates wouldn't work. Various pieces of that system is built on a bunch of other subsystems. So this new release should have a whole lot of extra stability in it as well. All right. I think last we got Salim. You ready to go, man?
Yep, I'm ready to go.
All right.
Basically, this is going to be a little bit of a behind the scenes look at some of the work we've been doing on the builder services. There's no user-facing UI here, but this is something that's important for the robustness of the builder services. So I have a dev environment that I'm going to do the demo. The important things are to note the window on the top right is showing some debug output from the job server, which is our service that helps manage some of the actual builds. And then the bottom right window is some debug output from a builder worker, which actually does the builds. I've also changed some of the timeouts here to make them shorter just for demo purposes. Normally, they would be a little bit longer. So what happens normally is that when we have build workers and they're ready to do work, they send a heartbeat to the build job server, and the heartbeat's used to schedule builds to those workers that are ready. Now, what happens until recently is that once a build job starts, then those heartbeats actually are paused. So what that means is that the build worker can get into a bad state and never send another heartbeat back again, and the job server would think that all is fine, but it's not actually all fine. The other case that is kind of a bad case is you can have a build job that starts up, it runs infinitely. Let's say there's an infinite loop in your build. That never gets resolved. So both those things are now resolved with this change we've done. So I'm going to kick off a quick build here. And you'll see some output happen. The job's been kicked off. It's happening here on the bottom right window. I've put in a little bit of a sleep statement just so I can shut down this worker before it would succeed or fail the build. But I'm going to wait for a second and let it send this heartbeat while it's doing some work. So you can see now we have this busy heartbeat show up on the top right. So now I'm just going to Control-C and kill the worker. And now we'll just kind of wait for about 15 more seconds for the time where the next heartbeat should show up on the build worker. It didn't, and you can see that because it missed heartbeat, it sent the state back to pending. So what's going to happen now is when another worker is available, this build will be resumed again. So I'm going to just restart this worker, and you can see right away it's gone back and scheduled that new build, dispatched it to the worker, and things are happening the way we expect them to happen. So that's phase one. Now phase two is the part of the build that, let's say this build keeps going and going forever, we want to be able to stop it. I've set that timeout to about 40 seconds here, just for demo purposes. So in the next 20 seconds or so, we should see that this build gets failed. And I think that's basically happened right now. Because of that hard-coded timeout, we've expired this build and failed it. So in those cases, the real timeout is probably going to be much larger. It's going to be maybe 90 minutes in our production service, or we'll configure it to some large enough value. But there'll be some point after which we will just stop and fail those builds if they exceed a certain time. So that's it for the demo.
Okay, that's the end then of demos for today. Thank you everyone for joining. Download the new release, give us some feedback, and we'll see you next week. See you later.